All right, in this video, we are going to talk about combinations of functions. So what this section is about is taking two functions and then combining them in certain ways to make more complicated functions. Okay? And so most of the ways are going to be pretty straightforward. You can see four of them right here. So we have f plus g, f minus g, f times g, and f divided by g. All right, and so how this notation works, it looks a little bit weird if you first, when you first see it because of these parentheses. So first off, when you're doing this, for instance, the first function that we're looking at, its name is f plus g. Okay, so that's what it will look like. The thing is if I write it like this, because it has this math symbol in here, it looks really odd. And if you aren't careful, it's fairly easy to probably misinterpret that. So it just doesn't look right because you think, okay, I have g of x here, and then plus f. So just to make it a little bit more clear about what this is, right? We put parentheses around the f plus g. So that indicates that, and remember back to function notation, that indicates that the name of this function is f plus g. Now, you don't see that a whole lot with the parentheses around the name. You usually only see it, especially in this class, if it's one of these combinations of functions that we talk about. So because the name has a math symbol in there or something that can be interpreted as a math symbol, then you'll usually see parentheses around the name. But that's all this is, okay? All right, so just like any function, we have the name, and then we have the variable that you're going to be plugging stuff into. And then over on the right-hand side, we have the formula, right? The formula here is really simple, right? It's just take the function f and then put a plus and then put the function g. So we're essentially adding these two functions together to make a more complicated function, okay? So that's how this notation looks. This is the name, f plus g. It's in parentheses because of the fact that it has a math symbol in there. Over on the right-hand side is basically the formula, right, for assembling or building the more complicated function. Take the function f and then add the function g. Okay? So that's sort of how these things work. All right, and we have these four, f minus g. Right here, we just take the formula for f and subtract off the formula for g. F times g. There, we just take the formula for f and multiply the formula for g to get a new function. And then f divided by g. Take the formula for f and then divide it by g. All right. So those are 4 out of the 5 ways that we'll take a look at. These are, once you get past the notation, most people are fine with this. These are sort of the ones that everybody's most comfortable with because you're already familiar with adding, subtracting, multiplying, and dividing. There's just a few algebraic things that you need to watch out for, but for the most part, people feel pretty comfortable with these. We do need to talk about what the domains of these are: f plus g, f minus g, f times g. And here you'll see this upside down U looking symbol. That just stands for intersection. Okay, so which basically just means it's what's common, right? There's f has its domain and g has its domain. So the domain of f plus g, f minus g, and f times g will be all of the numbers that are common to both f and g, the domain of f and the domain of g. Okay. All right. It's similar for the domain of f divided by g, except that because you have a division, right, with here, you're going to have to exclude values where the bottom part is equal to 0. Okay. Just like you would because you would have a division by 0 problem. All right. Most of the time here, if you get the domain like you're used to doing it in the previous sections, then it works pretty much exactly the same. Okay. All right, so in this problem, we are going to take a couple of functions. One is f of x equals x squared, and the other is g of x, which is x plus 3. And we are going to calculate f plus g, f minus g, f times g, and f divided by g. Okay, so first off is f plus g. All right, to build f plus g, you would just take the formula for f, right, which is x squared, and then add the formula for x plus 3. And you would simplify that if you can. In this case, you can't, and so that's it. Okay, but you can see f plus g is a more complicated function than either f or g, right? So we took these two kind of simple functions and made a more complicated function out of the two. All right, next up is f minus g. F minus g, that can be a little bit tricky for people sometimes. The formula for f minus g, as we saw in the previous slide, is just the formula for f of x minus the formula for g. But now the issue, right, is that if g has multiple terms like this function does, then those terms need to be put inside of parentheses. Or you have to remember to distribute the negative sign through the parentheses. All right, so this can definitely be simplified by distributing that negative sign through the parentheses. So you get x squared minus x minus 3. So you've got to remember, if this g of x, the second function, the one you're subtracting, has multiple terms, put it in parentheses so that you remember to distribute the negative sign through the parentheses. Okay. All right, next up is f times g. All right, and to make f times g, we would just do the formula for f of x times the formula for g, which should be x plus 3. Again, that needs to be in parentheses since it has multiple terms here. Okay, and we can clean this up a little bit by distributing the x squared through the parentheses. So we would get x cubed plus 3x squared. Okay. And then f divided by g. All right, that would be the formula for f of x, which is x squared, divided by the formula for g of x, which is x plus 3. Okay, and that is it on this one, right? You cannot simplify this anymore. So you have to be extremely careful, right, when you're doing things like that. And so sometimes what people will end up doing is they'll end up canceling out things that they cannot cancel, right? And the key to that, to not making that mistake, is to remember that if you can cancel a factor out, right, you can factor it out first and then cancel, okay? So here down the bottom, a lot of people would be tempted to cancel out that x, which is incorrect. You can't do that with an x on top. So you always want to ask yourself when you're about to do that, if you find yourself making mistakes like that, is you need to ask yourself, hey, can I factor an x out of here? Can I factor an x out of here naturally? And you can't do it, right? Because the 3 does not have an x. That means that you cannot cancel the x with one of these in the top, okay? X here is not a factor, it's a term, right? It's being added to the 3, all right? So before you cancel anything out, you can always factor out and then cancel the common factors. All right, and so that's it on those 4. Now, it asks us to find the domains of each of these. So in order to do that, what you would do is look at the domain of f. Here, f is a polynomial, right? X squared, right? Quadratic. So its domain is all real numbers, right? Minus infinity to infinity. There are no problems with this, right? Remember, to find the domain, we said so far in this class, right? At this point in the class, you just really need to kind of check 2 things. Number 1, check, are there any fractions with variables in the bottom part? The answer is no. for f, then the next question you need to ask yourself is, are there any even roots, square roots, fourth roots, sixth roots in the function? Again, the answer is no for f, right? There's nothing here. And so therefore what you would do, right, is at this point in the class, the domain is all real numbers, okay? And you can see it's the same thing for G. G doesn't have either the division by zero problem nor the even root problem. So again, the domain is all real numbers. So now to find the domain of f plus g, f minus g, and the domain of f times g, then what we would do, right, it would be whatever numbers are common to the domains of f and the domains of g. Again, so that would be the numbers that are in both the domain of f and the domain of g. Well, the domain of f is everything, and the domain of g is everything, so what's common between everything and everything is everything, right? So here the domain is just all real numbers again. Now, for the domain of f times g, right, it's going to be everything except, right, places where the bottom part of f divided by g is 0. All right, so the bottom part, right, of f divided by g is x plus 3. If you set that equal to 0 and solve that out, you get negative 3. Okay, so the domain of f divided by g will be what's common to both, right, the domains of f and the domain of g, except negative 3. So everything except for negative 3 would look like this. In interval notation. So those are the domains. All right, so I don't know if too many of our problems involve finding the domain here that we have to work in Newton, but that's how you would go about doing it. Okay. All right, and so that is it for the first part here. We are going to separate this second part out into its own video on composition of functions.